All right, so I am a member of the board at EcoWave Power, so I'm going to give you a small update on what our company is doing. I'm not going to show you this video because it's a bit too long, but please download the presentation on the Naventus website, and so then you can go through it. But I want to show you what we're doing. We have a very, very simple system that we have built over since 2011, and it consists of floaters that are going up and down in the waves, just like you can see on the video. And it pushes a piston up and down and compresses hydraulic fluid that in turn pushes the hydraulic motor and the generator. So it's a very simple system, and it's a modular system. Basically, we are building these systems off-site, ship them over to industrial piers, and put them onto the pier, and then install the floaters. And then we can jack up the system to the grid in the port. So we can maintain the whole system on land and be very efficient in our industrial future rollout. As I said, this has taken a lot of years and gone through a lot of trials. We started in 2011 with the wave pool trials, and then later moved on to doing a prototype in Jaffa, Israel. And then in 2016 we did a demonstration project in Gibraltar. That one has been in operations ever since, and the steps that we are taking now are in a pre-commercial phase with a project that we are running together with EDF, which is the French utility, one of the world's largest energy companies. So it's a 50-50 owned joint venture, and we are building this 100 kilowatt station in the port of Jaffa, Israel. Here you can see some images of the different projects that we have been running. So the last project that we did in Gibraltar, what we wanted to prove there was that we could safely build and connect this system to the grid without breaking the grid. And we also wanted to safely operate the system for a number of years to be able to say that we can endure storms. So when we have a storm with our systems, the floaters will come up and stay up in a locked position until the storm subsides, and then go down again and keep on going. And then we also wanted to show governments that are, when we get an environmental permit, our system has little or no environmental impact. So that's also a big thing, to have a speedy project development once we are up and running. Yeah, and we have also built our own SCADA system. So next steps for the Gibraltar project is basically we have proven everything that we want to prove. So now we are applying for a Horizon 2020 grant. It's our second. We got the first one, and now we are applying for a grant to build a industrial grade system, and that, what I mean by that is 2 to 5 megawatts and up. And then we had the EDF project, the one in Jaffa. It's this system. What we want to prove here is that we can have a financially viable product. It's basically doing this project, 100 kilowatt, we're going to be able to, that's the goal of the project, is to be able to prove that we have the financials to go forward on an industrial scale, to roll out project after project. This project is being built right now, as you can see. Siemens is our partner in doing everything electrical, and EDF are helping us with the SCADA systems, and we are doing everything else. And the patents are for the system is all ours. We are planning to have this project finished in the summer, and then do test runs for the year out. So that's the hardware side of things. My history is actually that I come from the wind power sector, and have been working for Eolus Wind, among other things. So 2 great companies presenting here today, Climon and Eolus, and then us, of course. I was working a lot with project development. So what you need to do, looking at projects such as ours, we have thousands of ports to choose from, literally thousands. So what we need to do is just focus on the best ones, and also be able to distinguish which ones those are. And that's, of course, a combination of wave heights and electricity prices, the easiness or how easy it is to get site concessions and licenses. We have plus 20 projects today that we are developing, and that's going according to plan, so we're happy with that. We get a lot of requests for these projects, not only investors that are contacting us to own these assets, but also ports that wants to have these systems up and running. So you need to be able to handle all these projects. So basically, we do have a bunch of these projects are in the project, the planning phase, but also a few of them are in the execution phase, such as the EDF project. And then one major thing for us is that we always want to be able to operate our own systems. So that for us is 25 years of steady income for every project that we build. But on top of that, we of course have our revenue models that in general are 3. Either we build and own these systems ourselves, or we do it as a joint venture, where EDF would be one example. We can always transfer our own assets to somebody that are willing to earn less than what we are. And as I said, we don't build. We have our projects plus 20. We don't build unless we have the project financed one way or another. For instance, the joint venture project is 50% financed by EDF and 50% is financed by the Ministry of Energy in Israel. So we're conserving our investors' money in a good way, I think. And then lastly, we always want to operate the systems, as I said. So next step for us, complete the Jaffa project, show that the system is viable as an investment grade, and then roll out this system one project at a time to begin with. And I hope that we, in a short time, can reveal our plans for our first megawatt scale project. And with that, I'll take your questions.
Great. Thank you. Please, center stage with me. How about competition?
Imports, none. Imports, none. It's wave power is mainly offshore and in a variety of different either they are buoys going up and down, or they are on the bottom of the seas with streaming water, basically.
That's something else.
Yeah.
You mentioned the private-public collaboration in Israel. What are the opportunities and the challenges in these types of ventures?
For us, basically, we will present the project to a country, and then there will be a competition of some sort. So our technology will be compared to other types of technology, since we don't really have competitors. So there is that, but so far we haven't had much problem, actually. It's we are in the middle of a great big announcements coming up, but I can't talk about it, unfortunately.
Let's see what questions we have in the app. How many homes can be supplied with electricity from installations on a pier like the one we saw in the last slide in Jaffa?
Sorry.
How many homes can be supplied with electricity from installations on a pier like the one we saw in the last slide from Jaffa?
The Jaffa project is a super tiny project, just so you understand. It's the proof that what we want to do there is to prove that the system works. I'm guessing now, but it's I would say 10, something like that. It's not many. The whole idea is to show that we can scale. Basically, that project is 1/50th of a commercially sized project.
1/50th.
Yeah, so it's so you should.
So that would be 500 homes from the next normal scale.
No, way more.
Not me doing the math right, obviously.
Yeah.
But how many homes in a standard project that you would go for?
A couple of thousand.
A couple of thousand.
Yeah.
Right. Do you think wave energy will be as profitable as wind energy soon?
No, I don't. I don't think so. I've invested in wind power, and it's basically, or profitable, sorry, that's actually not as efficient. It won't be as efficient as wind power, because wind power has been developing for 30 years plus, and then if you want to go even further to the 1600. But the big advantage for us is that if I can get to become half as efficient as wind power, our revenues per kilowatt hours are maybe 10 times higher. That's the big advantage for me, or for our company. So if you take Israel, for instance, the electricity price is 4 times higher than in Sweden. So I don't have to be as efficient. And then you have the grants, because it's novel technologies. As I said, the whole installation in Israel is funded by somebody else than us. We see that for a few more years going forward, that we're going to be helped by governments.
And I guess the installation costs and the maintenance costs are lower than...
Way less than wind power,
yes.
Way less. We have an industrial-sized project. The prices are mainly man-hours, nothing more.
Great. The iPhone just locked itself. What's the difference between the new project with EDF and Jaffa and what you did in Gibraltar?
Oh, yeah, so basically the Gibraltar project proves that the system doesn't break down, and that the electricity grid doesn't break down. The Jaffa project proves that we have a financially viable product. So we need to be able to show returns on that project. That's the goal of the whole.
So this was pretty much a test bed, you could say, yes. So
this is the last step before the industrial rollout of every other future project that we have.
You mentioned that the appliances will be, they've raised themselves when it's really stormy.
Yeah.
And what we see now in the effects of climate change, that we get more dramatic weather. How do you take this into your calculations, that they might be sort of in an up position more than you?
Exactly. I mean, I don't foresee it like that. We're going to have storms, sure, but But we just have to have robust systems enough. And I can tell you that if you watch the video, you're going to see some pretty hefty storms that we have put the system through. So.
And more waves is more energy, so that's also
more
good,
waves
right?
is more energy, yeah, that's
Great.
correct.
We have one final question. Let's see, how durable are your facilities?
How durable? I mean, the whole installation is situated on the pier, so in a container. So that part of the system, you can't break it. The floaters themselves, they do require maintenance. Mm-hmm. So we do have, for the large-scale projects, we have one person attached to the project, so as a site manager, so always looking after it. But the cost of one floater is very minimal, so that's not a great concern for us. And
if one breaks, that doesn't affect the entire chain?
No,
well, that's
exactly.
Important.
That's important, yeah.
Well, let's see. Any more questions? You can also ask questions in the room if you like, because we do have hand microphones somewhere and a runner. So here's one. Emma will do. And please put your microphone to your chin so we can hear you clearly.
Yeah, hi there. I'm wondering about the cost per megawatt hour on a smaller scale project, like a 5 megawatt or 10 megawatt project.
We haven't calculated that yet. This is what we actually have for this project. So this is what the EDF project is there to prove. But as I said, even if we are half as efficient as wind power, then we're still happy.
It's still good money.
Yeah.
Thank you for your question. Do we have any more questions in the room? Or if you want to send it in via the app? Here's another one. Great.
Yeah, any plans to install this on oil rigs?
Yeah, we have been approached by oil companies in regards to that. So it's correct that it would be feasible, but the maintenance on... My main objection against wave power is the maintenance cost. And so I love the fact that we are on piers and that it's really cheap to have a site manager work there. So that would go against the whole efficiency part about maintenance. But you're right, it is a good site for waves.
So just on that, a follow-up question.
Hang on, we need the microphone for the broadcast.
Thanks. A follow-up question on that, just on maintenance briefly. What's involved there? What can go wrong?
Lubrication, repainting of the floaters, that is the main parts. We have also installed solar panels on some of these units, so clean them off. It's minimal. It's like solar panels, more or less. You say that they don't have any maintenance, but they do.
Well, thank you very much, Elias Jakobsson, and best of luck.
Yeah.
Thank you.
Thank you.